In this lesson, we will be learning how to apply transformations to a function. We will be going over the rules and the common mistakes that people usually make. Alright, let's get started. When we take a look at a function, f of x is equal to x squared, we usually like to divide this into two sides. We have the left side and the right side. So let's take a look at a couple rules first. Rule number 1. Compound transformation always apply what is stated first. So when you have multiple transformation, always apply what is being described first. Rule number 2, always focus on the left side of the equation rather than the right side. This will eliminate a lot of common mistakes and help us determine what to do to the equation. Rule number 3, ask whether the transformation applies to the whole function f of x or just replacing the x on the inside. Alright, let's take a look at an example. Given f of x is equal to x squared, can we apply translation up by 1 and translate right by 2? If we remember on our transformation flowchart, translate up by 1 is the same as adding 1 on the outside, and translate right by 2 is the same as subtracting 2 on the inside. Let's focus on the left side of the equation. Adding 1 on the outside will be the same as f of x plus 1. And now if we examine it closely, this notation f of x plus 1 is telling us the whole function f of x needs to add 1, which our f of x is the same as x squared, so our x squared needs to add 1. So now let's rewrite our equation back to our f of x. So we will have f of x is equal to x squared plus 1. Then we are ready to apply our next transformation, which is translate right by 2. This means we need to subtract 2 on the inside. We will have the equation f parenthesis x minus 2 close parenthesis equals to open parenthesis x minus 2 close parenthesis squared plus 1. Realize how originally we have an x on the inside, but now it's being replaced by x minus 2. So this means that every x that we have, we will need to replace into x minus 2. And of course, we still have the plus 1 left over from the outside. Now, let's take a look at a more extreme example. If we have f of x is equal to x squared plus x, and we apply the same transformation, translate right by 2, what will happen to our equation? If we focus on the left side, we will have f parenthesis x minus 2 on the inside, which means that our original x is being replaced by x minus 2. So all the x needs to be replaced by x minus 2. We will get parenthesis x minus 2 close parenthesis squared plus parenthesis x minus 2. Realize how our x got replaced by x minus 2, so all the x in our equation needs to be replaced by x minus 2. A key to success on applying transformation is always focus on the left side of the notation and ask yourself whether the transformation applies to the whole function f of x, or does it just replace the x into something else? So the next example, f of x is equal to x squared plus 1. And can we apply a horizontal stretch by 2 followed by a vertical stretch by 3? Horizontal stretch by 2 is actually multiplying 1/2 on the inside. Remember, horizontal stretch and shrink is by a factor of 1/8. So our 2, which is the factor, is equal to 1/8, and our a is equal to 1/2. So we will actually need to multiply by 1/2. Whereas vertical stretch by 3 is just simply multiplied by 3 on the outside. So remember, horizontal stretch and shrink always has a kick to it. There's always a twist that we will need to flip the number when we solve it. Whereas vertical stretch or shrink, the number is direct. So whatever number we see, we can just go ahead and apply that number. So now let's jump into the equation. F of x is equal to x squared plus 1 is our original equation. Now we have to apply horizontal stretch by 2, meaning multiply 1/2 on the inside. So we will get f parenthesis 1/2 x, which is equal to parenthesis 1/2 x squared plus 1. If we focus on the left side of the equation, our x got replaced to 1/2 x, meaning our whole equation on the right side, any x needs to also be replaced by 1/2 x. Let's rewrite the equation back to our f of x, which is equal to 1/2 x squared plus 1. So we are ready to perform our second transformation, which is vertical stretch by 3. This means we have to multiply 3 on the outside of the function. So we will get 3 bracket 1/2 x squared plus 1 close bracket. Realize how the 3 is multiplying to the whole function. And what is our whole function? 1/2 x squared plus 1. So we will need to multiply the 3 to all the stuff in the function. And we will obtain 3 parenthesis 1/2 x squared plus 3. So there is a common mistake that people always make. F of x is equal to 1/2 x squared plus 1. Multiply 3 on the outside. If you focus too much on the right side, you will end up getting f of x is equal to 3 parenthesis 1/2 x squared plus 1. Realize how if we focus too much on the right side, we will just put a 3 on the outside. Whereas we should have put 3 on the outside of the whole function, meaning 3 needs to multiply to the whole function and not just the x term. So make sure we always focus on the left side of the notation instead of jumping straight into the right side, because you will make a mistake for sure. So let's take a look at our last example. F of x is equal to parenthesis 3x close parenthesis square. And we want to perform translate right by 2. This means that we have to subtract 2 on the inside. So if we rewrite the equation, f of x is equal to 3x squared. Translate right by 2 means subtract 2 on the inside. So we will get f parenthesis x minus 2 close parenthesis, which is equal to 3x minus 2 squared. But be careful, we have to put a parenthesis around our x minus 2. If we take a look at the notation, 3 is multiplying to the x, and our x is now being replaced by x minus 2. So we would have 3 times the whole thing that got replaced, meaning x minus 2. Which if we distribute in the 3, we will get 3x minus 6 squared. Or we can keep it in the notation, parenthesis 3, and then another parenthesis, x minus 2, close parenthesis, square. Either notation are fine. A common mistake that people make is f of x is equal to 3x squared. They will focus too much on the right side and get f of x is equal to 3x minus 2. Realize how they know they have to subtract 2 on the inside, but they just subtracted 2 to the x. They forgot the order operation. 3 is multiplying to the x, so the 3 is supposed to multiply to the x, but in our notation, when x got replaced by x minus 2, they only multiplied the 3 to the x and forgot the x has become x minus 2 instead. So once again, when we apply our transformation, always make sure you focus on the left side of the notation and ask yourself what happened to our notation. To summarize what we have gone over, we learned how to apply transformation to a given function. So we have 3 rules. The first rule is compound transformation always apply to what is stated first. Second rule is always focus on the left side of the notation, then go to the right side of the notation. Lastly, we want to ask ourselves, does the transformation apply to the whole function, which is f of x, or just replacing the x into something else? So we have to be very careful and ask ourselves, what is it that we will end up getting? So if we focus on the left side of the notation, it will tell us exactly what we need to perform, whether to the whole function or to the x. And now we have successfully learned how to apply transformation to a given function. If you guys like that content, please feel free to smash that subscribe button and help support the channel.